All right, so we're going to talk about quadratic functions, and there is the standard form, which is f of x equals a times x minus h quantity squared plus k, where a cannot be equal to 0. And the graph will be a parabola whose vertex is hk. The parabola is symmetric with respect to the line of x equal to h, and if a is greater than 0, it's going to open up. If it's less than 0, it's going to open down. There's also the general form, which is f of x equals ax squared plus bx plus c, and the vertex of the parabola is going to be negative b over 2a, and then find the function at that value that you find for x. So f at whatever your x value is. So, graphing our quadratic functions with the equations in standard form, we'll have some steps that we'll use. First, we're going to basically figure out if it opens up or down, and then determine what the vertex is, find any x and y intercepts, plot the points and any additional points that we need. We'll find the domain and range, and then the max or min. So we've got a couple of pictures would be an opening upward and an opening downward. And then we also have graphing quadratic functions in the other form. We'll still do the same steps, finding the vertex differently. We'll still have the same kind of graphs that happen. And then we'll figure out the min or the max. And the min or the max with our quadratics are typically going to be your vertex. So depending on what type of vertex we've got. But that's really what you're looking for is as far as the min or max, because this is either going to be your minimum point or your maximum point will be on that vertex. All right, so let's go look at example 1. So we are going to graph using our end behavior, our vertex, and our x and y intercepts, and then we'll find our domain and max or min. All right, so our first problem is going to be f of x equals negative 2 times x minus 3 squared plus 8. Now what we need to do first off is recognize the format. So this is f of x equal to a times x minus h squared plus k. So we are looking that our vertex will be our hk formula. Because of the format of our equation. So that will be our vertex. All right, so let's go through our steps. And you really don't have to memorize the steps. They'll start to become second nature as you figure out what you're doing to graph. But the first thing we want to do is look at what our a is equal to. A is equal to a negative 2, which tells us it's negative, and because it's negative, we know that our parabola will open like this. Our second part is finding our vertex, and we've already discussed that the vertex will be hk. So our h is equal to 3, and our k is equal to 8. Remember, on the h, it's going to be opposite of what you're looking at because the format is x minus h. So that's why it's a positive 3 and not a negative 3, because it's following the format of the f of x equation. So it's always going to be opposite of what you're looking at for the h part, but the k will be exactly what you see. So our vertex will be 3, 8. All right, so step 3 will be our x-intercepts. And our x-intercepts are always found the same way. We are going to set our y equal to 0. So, going to our original equation up here, we will have 0 equals negative 2 times x minus 3 squared plus 8. So we're basically going to solve for our x value. So I'm going to move the 8 over, doing the opposite of what's being done. And then we'll divide by the negative 2. And negative 8 divided by negative 2 will get us 4, equal to x minus 3 squared. And then to continue to solve, we'll take the square root of both sides. Remember, whenever we introduce that radical, it becomes plus or minus. And the radical takes care of the square. So we have x minus 3 plus or minus 2. We'll add the 3 over. And we get 3 plus or minus 2 equal to x. Well, what this means is we have 3 plus 2 and 3 minus 2. You can't just combine 3 plus 2 get us 5 because there's plus or minus on that 2. 3 plus 2 will get you 5, but 3 minus 2 will get you 1. So this will give you the point of 5, 0 and 1, 0 for your x-intercepts. The next step will be to find our y-intercepts. So for the y-intercept, x equals 0. So this will get us y equal to negative 2 times 0 minus 3 squared plus 8. So again, I'm plugging in the value. So this will be negative 2 times negative 3 squared plus 8. Negative 3 squared will get us 9. Negative 2 times 9 will get us negative 18 plus 8 will get us negative 10. So our point will be 0, negative 10. And yes, you could plug that into the calculator once you get that. But it's always good to practice our math skills. All right, our next step will be to graph what we have. We have the y-intercept, we have the x-intercepts, we have the vertex, and we know that the graph will open downward. I know that my high point on my graph, on the axes, the y-axis, is going to be 8, and the low point will be negative 10. And as far as the x's, I need to go to at least positive 5. All right, so let's do step 5. We will graph. So we're going to need kind of a long graph because we have so many values. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9. 6, 7, 8, 9. Okay, so let's graph what we know. We know the vertex is 3 and up to 8. And we know that the x-intercepts are at 5 and at 1, and the y-intercept is at negative 10. We also know that this is parabola, so it should be somewhat symmetric, which can help us graph it. So we're going to grab our vertex, come back down, and make it look somewhat symmetric. All right, now that we've drawn our graph, we have an idea of what it looks like. We can figure out our domain and our range. So the domain, again, is the x, the left side of the x to the right side of the x, so negative to positive. And it has 2 arrows pointing, continuing on. So it will be negative infinity to infinity, or all real numbers. Our range starts from the negative values of the y and goes up. We are at negative infinity, and we go all the way up till we hit the vertex at 8. So this will be from negative infinity to 8 with a bracket. And then our last part to understand is going to be the max. And the max will be what the vertex is, because that is our maximum point on our graph. All right, let's go look at another function and let's graph that one. Okay, this will be example 2. We have f of x equal to x plus 3 squared plus 1. I am going to rewrite this as f of x equals x minus a negative 3 squared plus 1 because I want it to look similar to the standard form that we're used to. So remember on the last problem I told you it's going to be opposite of what you see. If we match it to the form, we can see that it's actually going to be a negative 3 here, or opposite of what we're looking at when we look at our HK. Okay? All right, you do not have to rewrite it in this format. I just want you to make sure that you see that when you're matching, it has to match exactly with the negative sign. And that's why we know that our H will be a negative 3. All right, first step, our A, we don't see a number, so we know that it's 1. What we care about is that it is positive. That tells us that our graph will open like this. Step 2 is our vertex. Our H is equal to negative 3, and the K is equal to a positive 1. So that tells us that our point will be negative 3, 1. All right, next step. We have the x-intercept, where y is equal to 0. So 0 equals x plus 3 squared plus 1. We'll subtract the 1 from both sides. And we get negative 1 is equal to x plus 3 quantity squared. When we take that square root of both sides, we know, again, that it's going to be plus or minus. The square root of negative 1 is I. It is imaginary. So I can go ahead and finish solving this so that you see you end up with negative 3 plus or minus I is equal to x. Well, that I is imaginary. It means it doesn't exist. So there will be no x-intercept. So once you get to the spot here, you'll know when you take the square root of any negative, it's not going to be an x-intercept. All right, step 4 will be our y-intercept. And again, that's where we set x equal to 0. So we'll have y is equal to 0 plus 3 squared plus 1. So that'll get us 3 squared plus 1, which will be 9 plus 1, which equals 10. So our y-intercept will be 0, 10. And then step 5 is going to be our graph. So we only have 0, 10, and negative 3, 1 for any of the values that we have at this point. So it's going to be an all positive graph. Okay. All right, so our vertex is at negative 3 and 1. And then our x-intercept is at 10, which will be right there. And we know that it's a symmetric graph because it is a parabola. So we know that it's going to kind of come in from here, come down, and go back up. Just make it somewhat symmetric. I'm a little squiggly over here, but it'll be fine. It's just a sketch. It does not have to be perfect. And on this one, we're not going to find the domain, the range, or the minimum or max, because those are pretty standard once you've done the first one. All right, let's go look at examples. Actually, let's go ahead and do our domain and range, just to make sure you have a good understanding of it. So number 6, domain is going to be, again, if we're going with the arrows, so it will be negative infinity to infinity. The range comes from the bottom. We're going to hit the first value is going to start at that 1. and then it's going to go all the way up to infinity. So it will be bracket 1, because it includes it, and infinity. And then for our value, the last one was a max, because it hit the high point of the graph. This one hits the low point, so this will be a min, and it will be -3, 1, which we understand is also our vertex. All right, so let's go look at another example. This will be example 3. And this one is f of x equal to -x squared minus 2x plus 1. This one happens to be in the f of x equal to ax squared plus bx plus c format. So it's in a different format, so the vertex will be a little bit different. We're going to start the same and figure out, does it open up or does it open down? So our a in this case is still at the beginning. It's a -1, which tells us it's negative, which tells us that the graph will open down. Now to find our vertex, the first thing we need to know is a is equal to, we've already found that, -1, and our b is our second value at -2 in front of the x. So the x will be found by taking -b over 2a, which will be -2 over 2 times -1. So make sure you bring all of your negative signs. This will get us 2 over -2, which will be equal to -1. And then we need to find our function at the value we just found. That's what it means, the function at -b over 2a. Find the function of the x value you just located. So we'll plug that into our function. So -1 squared minus 2 times -1 plus 1. So make sure if you're plugging in that negative, you square the whole value. So the negative out front will stick, but -1 squared will get us 1. -2 times -1 will get us +2 plus 1. And when we add those together, we will get a +2. So our vertex will be -1, 2. So this vertex takes a little bit more effort to figure out, because it's not just HK. All right, let's look at step 3. That's going to be our x-intercept. And again, our y is still equal to 0. So 0 equals -x squared minus 2x plus 1. And we're going to try to factor this. And it's easier to factor if we make our x squared a positive. So I'm going to multiply both sides by -1. And that still gets me 0, but it makes it x squared plus 2x minus 1. The easy way to factor is a times b gets you to your c. Our a is 1. This should be a times c gets you to b. Sorry, I have those two letters backwards. It makes a difference. And then times -1. And that 1 times -1 is -1, trying to get to a 2. So -1, there's only two values. -1 times 1 gets you -1, but when we add them, we get to 0. So this is not going to be factorable, so you're going to have to use the quadratic formula. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So you can use either equation. You can either use the original equation or the one once we made it more positive. I'm going to use the second one just because there's more positive values in it, but you could use either one. It does not matter. They are both correct forms of the equation. They're equivalent. All right, so we have -b, so -2 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Alrighty, and this is what our x will be equal to. So we have -2 plus or minus the square root. 2 squared is 4. -4 times 1 times -1 will be another +4, all over 2. So -2 plus or minus the square root of 8 over 2. And I can go reduce the radical of 8. Square root of 8, I'm going to break it down into the prime factorization. So 2 times 4 and then 2 times 2. So 2 times 2 times 2. I'm looking for groups of 2 because it's the square root. And I can bring out a matching set, which will get me 2 square roots of 2. -2 plus or minus 2 square roots of 2 all over 2. And I can factor out a 2. Get -1 plus or minus the square root of 2 over 2. The 2's will cancel. We're left with -1 plus or minus that square root of 2. And this means we have -1 plus the square root of 2 and -1 minus the square root of 2. We'll put those in the calculator and get 0.4 and -2.4. So that will get us 0.4, 0 and -2.4, 0 as our x-intercepts. All right, next part we need are going to be our y-intercepts. So the y-intercepts, again, are x equal to 0. So y equals -0 squared minus 2 times 0 plus 1. Well, the first parts completely cancel because they're 0. So we get y is equal to 1. So we'll have 0, 1 as our y-intercept. So now we can graph our function. We don't have very big values. We have a vertex of -1, 2. And then we have 0.4 and -2.4. And we have 0, 1. So I think we have room to graph it right here because it won't take up very much space. All right, so -1, 2, that's our vertex. And we have 0.4, so that's almost a half. -2.4, that's about -2.5. And we have our, oops, wrong spot, our y-intercept at 1. I graphed it down here, but it's actually up here. So always pay attention. And it's okay if you make little oopsies. If you have a pencil, you can totally erase. So there's our graph. Let's go find our domain. Our domain, again, we have both arrows. It's going to be -infinity to infinity. Our range will start at the bottom and go up, so -infinity all the way up to our vertex, which is 2. So -infinity to 2 with a bracket. And then we're looking at this will have a max value because it's got a high point on the graph. And the max, again, is still the vertex, -1, 2. Alrighty. So those are a couple of different graphs, some different things that you'll run into. This one has an easy y-intercept. It pops in easy, but sometimes your x-intercepts can be a little bit more work. All right, our next problem is on our handout, example 4. It says write an equation for each graph in the form y equals a times x minus h squared plus k, where a is either 1 or -1 and h and k are integers. All right, so for this graph, we have two graphs. We have A and B. So first one we're going to look at is A. And And again, we're writing the equation as y equals a times x minus h squared plus k. So what we need to know is our vertex so that we can plug in the h and the k, and we also need to know the value of a. So our vertex on our graph, we can go up. We're at 2 for the x value, and at 5, we're on this side of it, so -2, and then 5 for the y value. So -2, 5. And because our graph opens down, we know that the a is going to be -1. So remember, this is our h, and this is our k. So we will have y equals, following our format, -1 times x minus our h, whoops, I wrote h instead of 2, squared, plus our k. So we have x minus -2, so we'll clean that up. So x plus 2 squared plus 5. And you don't have to put a 1, you could just put a negative sign. And that would be it. All right, so let's look at part B. Part B, we can see that our graph is going up, so our a will be 1, but let's find our vertex first. Our vertex is going to be at 1 for our x value, and it comes down 1, 2, 3, so -3. So 1, -3, and our a is equal to 1. So again, we have y is equal to 1 times x minus our h of 1 squared plus our k. So it would be plus that -3. And you can just write -3 to start with if you wish. So y equals x minus 1 squared minus 3. And again, you can put the 1 out front, or you can just leave it without the 1. All right, our last problem is also on our handout. We have a manufacturer of a digital camera wholesales. The manufacturer of a digital camera wholesales the camera to retail outlets throughout the United States. The price demand function is P of x equal to 100 minus 2x. The revenue function is R of x equal to x times P. So it's x times 100 minus 2x, and both domains are 0 to 20. We need to figure out the shape of the graph, find the output that will produce the max revenue, what is that max revenue, and then what is the wholesale price per camera that produces the max revenue. All right, so example 5. Let's write down what we know. We have P of x equal to 100 minus 2 of x, and our R of x equals the x times the P of x, which will be x times our 100 minus 2x, which gets us 100x minus 2x squared. And I'm going to rewrite that as a -2x squared plus 100x, just because it might be easier to see what's going on with the graph. And it's going from 0 to 20. So if we look at this format, it's a little bit easier to see for the quadratic. So for part A, we wanted to know the shape of the graph. Well, this -2x squared tells us that the graph is going to be like this, because it's a negative. And we know that it will start at 0 and go to 20, because that is what the domain is. That gives us an idea of what our graph will look like, and that's all we had to be able to do. The second part we needed to find was the output that will produce the max revenue. And that's going to be using our vertex formula. So that'll be -b over 2a, comma, the function at negative b over 2a. Because remember that the vertex is going to be either your max or min, and in this case we're looking for a max. Another reason we needed to write our formula, or our equation, in this format, because we need the a and the b. So we'll have negative b over 2a will be negative 100 over 2 times negative 2, which gets us negative 100 over negative 4, which will get us 25. So this will be the output for max revenue. So then we're going to find the function at 25 equals negative 2 times 25 squared plus 100 times 25. All we're doing is plugging in this x value into our formula. So when we plug that in, we'll get 1,250. So this is our max revenue. And then part C, we need the price per camera. So our P of x formula was given to us as 100 minus 2x. That's our price. And we know that the x that we found was 25. So 100 minus 2 times 25 will get us 100 minus 50, which will be 50. Okay. All right. That teaches us a little bit about some quadratics.